Hello, today I'll be covering a homework problem, and it's going to be from chapter 5.1. It's going to be number 33 or 34. We'll go with number 34 because that's a little bit fresher. So we have 34, and it's going to be double integral from 0 to 1 1 to 2 of 4. Oh, that's a y. Y oh my god. Y over x plus y squared. And it's going to be dy dx. So we're going to start with the U method, and we're solving for this part right here, and we're going to use, or it's from the integral of 1 to 2 with respect to dy, which means that anything but y can be a constant. And in that case, you'd be able to pull it out, but in this case, we're not going to be able to pull a constant out. So we're going to be using the U method, and we're going to say, let U equal to x plus y squared. And then we're going to take the derivative. So du is equal to 2y. And this is going to be dy. But notice here, let me get a highlighter. But notice here, we have a y dy, and we have the y dy right here. So what we're going to do is divide by 2. Divide by 2. And this is going to equal to 1/2 du is equal to y dy. Now we're going to plug it in, and we're going to say, we're working with the first part, so let me write that first part out. I'll write it up here. It's from 1 to 2 y of x plus y squared dy. And so we said from 1 to 2, and we put u, and then we said that we have the y dy, and it's going to equal to du. It's not nice. Let me redo that. how my tutor did it was they wrote it like this. They wrote it 1 over u, which was the x plus y to the second. And then what they did was they put what y dy equals to, and we said that y dy is equal to 1/2 du. So then they wrote times 1/2 du. And then we know that we're able to pull the 1/2 out. So let me mark that in red. We're able to pull this 1/2 over here. And this is equal to 1/2 integral from 1 to 2 of du u. And we know that the integral of du over u is equal to ln of u. And I'm not saying this like I'm a math genius. I'm just saying this like that's what we're expected to know. Like that's what the tutor said, what it was. So I'm saying that du the integral is ln u. So this is going to equal to 1/2, and it's going to be ln u, but we're not going to put the parameters just yet, the 1 to 2, because we have to substitute the u. And we said over here, we said right here that u is equal to x plus 2y. So this is really equal to 1/2 ln x plus y squared. And then this is going to be from 1 to 2. Now we can evaluate. We can evaluate for this one. And we're going to put, I'll just put it over here on this side. I'll say that it's not letting me write. Okay, there it is. Okay, then it says, then it's 1/2, and when we evaluate it, we're saying that it's the y that we're putting it in for. So it's going to be ln of 2 plus y squared minus 1/2 ln. We don't have to put the 1/2 here. We could leave that on the outside like that, of ln 2 plus this, and this is gonna be, it's gonna be y squared like that, but I should have put the numbers in. Oh wait, I messed up. Let me just forget about what happened here. We'll try this one more time. So the professor said do this equals to y like that. So now let's plug it in. It's it's going to be 1/2, and we're going to have ln of x, which is a constant, plus the upper limit, 2 squared, is 4. And then this is going to be minus ln x is the constant, plus 1 squared is just going to be 1. That's going to be like that. So we have, notice that the 1/2 is on the outside because it's going to be distributed to both the ln x plus 4 and the ln x plus 1. So now what we have is remember we had the integral of the whole thing of dy and dx. Now we're going to look at the integral of from 0 to 1. So we're going to say the integral from 0 to 1, and then we're putting the 1/2 right there, but we know that it can be a constant, so we just pull it out 1/2, and this is going to be ln x plus 4 minus ln x plus 1. Now at this point we want to separate the two, oh, and I forgot the dx. At this point we want to make it 2 separate integrals. So we're going to put 1/2 from 0 to 1 of ln x plus 4 minus 1/2, because you multiply it to that side too, from 0 to 1 ln x plus 1 dx. Forgot my dx right here. Okay. So now let's take this and let's write it so it could be neat. Let's write it all over again. So it's going to be 1/2 from the integral from 0 to 1 ln x plus 4 d of x minus 1/2 integral of 0 to 1 ln of x plus 1 d of x. So now we're here and we're going to be thinking, how do we integrate the ln of x plus 4? And how they did it was they used the u method, but they did it for separate parts. So they did this. They said, let this right here be A, and this right here be B. And so they broke it into parts and they worked on it one by one. But the neat thing about it is that when you get the first one figured out, it's nice because you can figure out the second one, and it's pretty much the same process. The only difference is that you have a different number inside the ln. So let's take this first part and let's examine it. So we're going to take 1/2 integral from 0 to 1 ln x plus 4 dx, and we're saying that this is for work A. So when we examine this, we're going to use the u method again, and we're going to say let u equal to ln of x plus 4, and then we're going to take du dx. So du over dx. And I guess something we should know is when the derivative of the ln is x plus 4, like that. And then what we're going to do is we're going to say du is equal to 1 over x plus 4 dx, because you're going to use integration by parts right now. And I'll get to that in just a second. To use the integration by parts, I want to start off with the equation, just saying it. The equation for integration by parts is uv, like UV light, and then voodoo, like the integral of voodoo, like v du. So UV voodoo. I just came up with that on the spot. So UV voodoo, it's like UV, so we have the U right there, but we don't have, notice we don't have a V in this. We don't have a V. So because we don't have a V to then put into the minus integral of v du, let me just write this. U V minus the integral of v du. So notice that we don't have a V. So what we're going to say is that we're going to say that dv is equal to dx. And then we're going to say the integral of dv is equal to the integral of dx. And then we're going to say v is equal to x. And now notice that we have all the parts. We have, let me use a different color highlighter. But now notice we have all the parts for this equation down here. We have the u, we have the v, we have the v, and we have the du. So what you're going to do is you're going to plug that all in, and notice that we're still working on integrating it. So now that we introduce integration by parts, we're working on this part right here. We're working on this part right here. And when we integrate it, then we want to evaluate it from 0 to 1. Okay. So now we have u, which is ln. Let me write it over here. Which is ln of x plus 4. We have v, which equals to x, but to make it neater, I'm going to write it out here in the front. Then we have minus the integral of v, which is x. And then we have du, and we highlighted du right here. And we said that du is equal to 1 over x plus 4 dx. Okay, so this can be rewritten as x ln of x plus 4 minus the integral of x over x plus 4 dx. To solve this part right here, the one where it says the integral of x over x plus 4, we have to use long division. So how we do that is we put x divided by x plus 4. We know that x goes into x once, so we have x plus 4, but then we change the signs because they're minus, and then we have a remainder of a minus 4. Now the remainder of minus 4 would be over, this would be over x plus 4. If I get this pen to write. X plus 4. So we go back here and we say x ln of x plus 4, and then we say that this is going to be minus the integral of x minus 4 over x plus 4. Oh, whoops. This should be a 1. Because we're stating that those two are equal. We're stating that those two are equal. So now we can see that this is d of x. So now we can integrate that. It looks a little bit easier to integrate. And when we integrate it, I think we would pull out the 4. Pull out the 4 in front. Let me double check. Because it's going to be x to the ln of x plus 4. And then the integral of 1 is x. Yeah, and it's going to be plus 4 ln of x plus 4. But that's a minus sign. So one thing that's really tricky is the signs. Like, you got to get the signs right. It would be a minus sign, but there's a minus out in front, so that makes it a positive. So now we have x ln of x plus 4. And then we have minus x. And notice what we're doing here is just doing the integral d of x like that. So we pull the 4 out front, and so we're saying minus 4 ln of x plus 4. But we got to remember that we have the minus sign out front, so this is a plus. So okay, so that's what we get. That's what we get. And now this whole thing is from the integral. If we look back over here, it's from 0 to 1, and we have the 1/2. So this whole thing is from 0 to 1, and then we have the 1/2. So now we can plug it in. Looks like a lot, but it gets easier. So we're gonna have 1/2, and when we put the 1 in for x, it's just equal to 1, and so this is going to be the ln of 5 minus 1. This is going to be plus 4 ln of 5. And then we're going to take this whole thing and subtract. And in here we're going to have the next part. So let me put these in parentheses. The next part, we'll notice that when you put in 0 to the x, it's just going to cancel out. and then for the negative x, it'll be 0 as well. But when we put it into the 4 ln of x plus 4, it's going to be 4 ln of 4, like that. So we can take off these here. Now, what symbol was here? Was it a plus or a minus? Let me double check because I just erased it. It's a plus. Okay. So now notice that we have checking to see what color to use. Guess I'll just use blue. Notice that we have ln 5 and 4 ln 5. We can combine like terms, so we rewrite it to 1/2, and it's going to be 5 ln of 5 minus 1 plus 4 ln of 4. So now this whole part, if we look here, this whole part is equal to this part right here. But we did that for A. So if you got up to this point, then I would suggest you know what to do for B. And the only tricky part is going to be your signs. And on the second part, just remember that your long division is going to be easier because it's going to be x over x plus 1. And when you make that into a long division, it's just going to be x over x minus 1 over x plus 1. So if you understood all that, you can do the next part.